The ship is about to explode, and you are going to die a very painful death. You have roughly 10 minutes left until the ship reaches critical damage.
Hi everyone. What we have here today is a demonstration of a prototype game built for Global Game Jam 2021.
Oh, you found a flashlight. I am sure that will come in handy. It isn't like you need a fire extinguisher or anything.
It was made by 3 programmers, Waye, Hache, and Brandon Webb. On screen, you will see the breakdown of tasks each person was in charge of. While each person had a task they were focused on, everyone was encouraged to share in any difficulties and possible solutions that they might have. The theme of Global Game Jam 2021 was Lost and Found. The premise of the game is that you are an astronaut lost in space, and you need to find 10 cores in order to restart the ship and make it safely to your destination. Alongside you for the journey is a very sarcastic AI that warns you of impending danger. You are introduced to some basic obstacles that need to be overcome, like fire that needs to be put out, and jumping puzzles. The game also has picking up and interacting mechanics to get the player involved in their own unique way. The game was built in 72 hours in Unity 3D, allowing us to use the built-in physics engine and range indicators in the inspector for easy adjustments. For this video, I'm going to be skipping around a bit, since it's a hide-and-seek game and we don't want to reveal all of the core locations in this short video. The first room you will find yourself in is the tutorial room. A simple start animation plays, and after 3 seconds you will gain control of the character and can begin exploring. Once you have found what you need to put out the fire, you can walk up to it and interact with it. Once you are finished with the tutorial room, you will find yourself in the first hallway. Damaged beams and tangles of loose wires are everywhere, but they do not require being fixed to complete the game. The focus is just on the locating of the 10 cores. Some cores are in plain sight of the player, while some are hidden a little better behind or underneath objects. Exploring the small map fully is the name of the game. The second room in the ship is the communal area, littered with drinks, food, and magazines all thrown about. Due to the loss of power, vending machines, water dispensers, and anything electrical not on the backup power supplies is not working. One of my favorite things about this game is that the bottles can be interacted with and thrown at tremendous speeds. Although, let's be honest, glass shattering would have made that particular interaction just a tiny bit better. Alright, let's get back to hunting some cores. The next hallway looks to be a storage room where robotics, food, drinks, and even plants are being stored. Racks upon racks of machinery and geodes can also be found when looking closely. Let's jump on one of these plants, and as we can see, it does have collision, but there's no physics attached, so it will remain in place. Moving on, we open the doors and see the mother core and command center for the spaceship. 3 desks with 2 keyboards each and 2 massive monitors. Probably not the ideal environment for getting work done. Also, I wonder what happened to all the other people aboard the ship. This mother core looks interesting. I'm also very curious how it works and who put it together. We can interact with it, but since we don't have all the cores yet, we cannot repair it. This corner of the room seems to be exclusively damaged parts put into boxes. And finally, the main terminal room and navigation center.
All the core fragments. Now you can throw them all willy-nilly into the mother core. Just eat it. NBD.
With about 3.5 minutes left, we interact with the mother core.
Hey, I think that fixed it. Well done, team.
Perfect.
Go us. Time for you to go home to your human partner and human child.
You know what? Let's try jumping up on this mother core. Oh, okay. That doesn't really do anything. That's cool though. We have a good vantage point from here. Okay, everything looks good. Let's go ahead and restart the main terminal and get back home.
One more joke for the road? Okay, why did the astronaut not like the restaurant on the moon? Because there was no atmosphere. It's funny because you almost died from an explosion which would have rendered you incapable of producing or consuming oxygen.
Humans don't produce oxygen. Perhaps this AI is feeling a little scatterbrained after the collision? And what a nice final ending animation, completed with a "you win" ending screen and congratulations. Since we're already here, let's take a quick look at the code and see what's going on under the hood. Before we get too deep into this, for most people who have participated in global game jams, you already know, but making a game in 72 hours does not give a lot of time for optimization. So if you see some part of the code that could have been optimized better, you are probably very, very correct. Now that the disclaimer is over, let's take a look at all the funny business. We have two main scripts that deliver the bulk of the work, the inventory and the interaction manager. In the inventory, we're first going to start a new list, get an int for core tracking, and 2 bools for having the flashlight and turning it off and on. We also have multiple game objects for win and lose panels, time tracking, item placing, crosshair, and animations. We have 2 cameras, one on the player and one for the ending animation, and a public text box where we write the subtitles. Moving down the list, we have some instantiations, as well as a starting coroutine for the wake up animation. Every time you see typewriter, that is subtitles being added to the screen, which you will see the code for down a little further. In Update, we are just checking for player inputs. In Gain Item, we are reading for collecting items and triggering based on what gets picked up. For do input, we check if the player has a flashlight to turn on or off. Further down, we have code for collecting the flashlight mentioned above in the inputs. We also have a core collection, which increments the core int and updates the text box where cores are displayed. A sound is played if a certain amount of cores is reached. Further interactions become available once certain core amounts are done. 10 cores are required for interacting with the main terminal. And when the main terminal gets interacted with, we can turn off the main camera, swap to the second camera, and play the animation. We then start the 40-second coroutine, which enables the animator of the ending camera, which plays an animation on awake. We also turn on the audio listener, since only one audio listener can be active in a scene at any given time. We turn off all the extra text components that are not subtitles, and we wait for 15 seconds for all that to play out. After 15 seconds, we can turn off the game panel and let the animation finish with another wait of 20 seconds. At 35 seconds, the animation has mostly finished, so we can enable the second animation of the ship taking off. We then wait 5 seconds for that animation to finish and then turn on the wing panel and turn off the time. The last few functions are for what was covered in the bulk of the previous code. The wake up function returns a wait of 3 seconds before allowing the player animator to be disabled, allowing the player to take control. The typewriter passes in a value and switches based on the value case, and the AI write at the end waits for 20 seconds and then wipes the screen of any text. Moving on to the interaction manager, we can now look at all the things the player can do. We have an enum for player actions, a carry distance, and interaction distance. We have ranges to modify them with, and 3 game objects. We also have the player camera, a raycast, UI text, and other interactables. For update, we are looking for something the player can hover over and interact with, and then map those according to what the player can do. As we move through the code, we see that there are 2 main interactions, one for left click and one for pressing E. We then decide what can be clicked or not, and perform those actions if raycast hits the target. We also have a simple quit out attached to the escape key. We are modifying the carry location based on a vector3 return, as well as returning an array of physics raycast data. Show interaction grab is for left click, and show interaction E is for the E interaction. That's fairly self-explanatory. Each interaction has a coroutine that waits for 5 seconds before disappearing from the screen. There is also a trigger placed at the end of the first room that stops UI text from being displayed after the player is done with the tutorial room, so they are not constantly reminded of what can be interacted with. Now that the bulk of the code has been shown, let's take a quick look at the final thing in this video, which is how the objects are organized in the Unity editor. There are 6 main components to the Unity editor to keep everything organized properly. The canvas, which is broken up into main, lose, and win panels. The player, with the camera and flashlight attachments. the scene, specific parts of post-processing and audio, then the cores and their placements in the scene, the lights and their placements in the scene, and lastly the tutorial room, aka the spaceship, and all of the props that can be found inside the spaceship. And that's all. I apologize that it took so long to upload a new video, but I am incredibly happy to share this with everyone, and I hope you are as excited to see it as I was excited to be making it. For the work of 3 junior programmers over 72 hours, I think things turned out fairly well.